Webinar is starting, everybody. I see people joining us. Welcome, welcome. Thanks for finding time on Friday, which is, it's almost weekend, so we really appreciate it. Yeah. Let's wait for a
Morning.
little for more people to join. Oh, I see Poland, I see Serbia, I see Hungary. That's good. That's good. Today will be very international session.
That's good.
Hello, Martin.
Good morning, everybody.
Yeah, let's wait a little for more people to join. In the meantime, mm, the session is recorded. Also, the presentation, so the materials, everything will be delivered to all of you after the session. So you can watch it, you can just listen, but I recommend to watch it because together with Martin, we have a lot of nice things to show you today. Okay, Martin, I think we can start. So maybe a short introduction. Let's start with you.
All right. Yeah. So I'm Martin. I can see some familiar names. So thanks for joining us today as well. So I think a couple of people know me already. Yeah, I'm working for SurgeX for more than 3 years now, and trying to help to understand power better and to understand our solutions better and where we fit into AV installations, but also where we can generate more benefit for the users and also for the customers. And we're working very closely together with our distribution partners. So we are working very closely with Modulit, of course, and Adam and I were permanently developing materials to make it quite easy to understand where do we fit and where we generate a better benefit.
Exactly. And from my side, I'm Adam Kaczmarek, product manager responsible for SurgeX devices in our portfolio, but not only. And let me onboard you all about what's the idea behind today's meeting. So, Modulit Solutions is the AV signal distribution company. We have a lot of devices about how to send the signal from point A to B. But we were trying to find something which can enrich AV IT installations. So, in terms of just sending the signal, we have it all. But in terms of power, well, this is the area which we can help you a lot. That's why last year we started our cooperation with SurgeX to help you to enrich your AV-IT installations with the power solutions. Because we think, not in all cases, but a lot of them, in a lot of projects, power in AV-IT installations is just, if it's working, like if there is an outlet and it's power flowing out of it, then it's done. But sometimes it's not, and we will explain you, or Martin will explain you today why.
That's correct. So then, yeah, let's directly jump into it. Um, I'm starting to share my screen. Here we go. Yeah. So first of all, yeah, power is, as Adam said, it's mostly there's just on every project they're just adding power strips and that's it. So it'll do. We can't see power, right? We can't see load or what's amperage. So that's why I wanted to help to better understand that to give you some basic tools, just to get your head around the installation and how to spec it in correctly. So we want to demystify power, right? Um, because after we are doing PDUs, so power distribution units. We are sitting more or less everywhere. So we have small solutions where we can sit behind the display. We have this typically rack solutions and also large format and standalone solutions. And so after we are doing power, it's we are fitting in a lot of projects, so we can handle digital signage, we can handle control rooms, we can handle conference rooms. So every area where we're using AV, we are also fitting into. And we're combining it with our software solutions. But the basics mostly is where people sometimes struggle, and that's where we want to help. So first of all, what I prepared is like a small how-to guide, so how to calculate the power consumption, and yeah, choosing the right SurgeX PDU. And first of all, we would just line out the equipment. I mean, that's obvious, right? So we would need the project bill of material, just to get our head around, okay, so which kind of signal distribution or screens or speakers are working within the project, and then we can line out the power consumption.
Okay. Let me interrupt you. Why this is important? Why we need to calculate this power consumption, power load? What can happen if we will, I don't know, exceed the limit or something?
Then it's not going to work. Then the power is not enough. When we are supplying not enough power, then in the best case, the equipment is just not working. In the worst case, it could be that the equipment is getting broken because of voltage fluctuations, or it's getting warm because there's a very low voltage in the line. And that's why we need to be, I wouldn't say we need to be physically 100% accurate. So mostly we're calculating the power in a very easy way, ballpark, because that will do. But of course, we need to be in the right region. We need to supply the power in the right region.
Okay.
And I brought a use case scenario with us. So that's a project we realized. It's a conference room scenario. And in there is an LED wall. It's a 4x4 LED wall, a sound bar, conference cam, a touch panel, and in the back end is working an Ethernet switch, an LED controller, and a room PC. So that's a typically Microsoft Teams environment. And yeah, we are searching for the right SurgeX PDU, right? And want to understand, okay, how do we combine all the equipment together? So that's why, first of all, as I said, we need to line out the equipment and we need to gather the power consumptions. And there are some pitfalls what I wanted to let you know how we can resolve that. So that's the list of the equipment which is used within this project. And first of all, I would go with the LED wall because everybody knows LED walls, they are quite power hungry. So that's why we need to take care of them. And what we are then doing is just going through the tech data sheets. And sometimes the manufacturers, they are not very detailed. So that's why I just wanted to explain how we are working around a bit around this fact. Because when it's a signal distribution unit, then yeah, everybody puts all the specific data about the signal into the tech data sheet, and power is mostly like, the little stepsister. So it's just get lost, or on the very end of the tech data sheet, a bit is mentioned about the power. And
Yeah,
that's
that's
why,
true. That's true.
yeah, that's why sometimes it takes a while to work through it, right? So in case of the LED wall, that is lucky us, quite easy. So that's the original data sheet, and we have a total power consumption in there in watts. Of course, we need to do the maximum, or we need to use the maximum wattage,
Hmm.
not the typically one, because it could be when there is a test screen on the LED wall and it's completely white, then it's going to consume 2000 watts max. So of course, we need to take into account that, right? Sometimes it happens that we need to calculate the power consumption because, yeah, the 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 devices sometimes they are running on AC, but they are also, especially the small signal distribution units, all, I would say almost all the small boxes you're mounting behind the wall, they're running on DC. And there are also some issues coming with it to find out the proper power consumption. And that's why I brought some basic knowledge about power in here. So the power itself is just calculated the voltage multiplied by the current, by the maximum current. And mostly we're using 240 volts to allow some overhead. So that because in some installations you're having only 220 volts, or in some regions, I know regions in mid of London, for example, they're having like 245, 250 volts straight out of the line. And that's also not very healthy for the equipment. And with DC power, especially when you're having these small power supplies, we are just transferring it into AC power because we are supplying AC power on almost all the our products, and then we would just multiply the AC power by 1.2. So I've chosen the camera for that, the Poly E7T, because in that tech data sheet, there is mentioned a lot of power information just jumbled up and mixed. So we're having something with 12 volt DC, we're having external power supply with 240 volts, or an 12 volt external power supply. And that's sometimes a bit tricky to find out the maximum power consumption, what we would need. So the AC one, for example, just shows, yeah, that's the minimal requirement for the power supply, but it's nothing to do with the actual power consumption. And that's why we would use the external power supply on DC. So that's 60 watts. And as I told you before, so we're going to multiply that by 1.2, ending up with 72 watts for our total power consumption on AC. And then, yeah, I collected all the power consumption of the whole equipment, and that's ending up into almost 2,300 watts. So now we're having our power consumption calculated, and now we can choose the right SurgeX SKU. It's, of course, it depends sometimes on the use case scenario. Is there a rack? Is there no rack? Do I have the space to mount something behind the LED wall or the screen? And I've chosen here two options. So option one would be our Defender Series Plus, which we are having new on the market since last autumn. And it's offered in two options, in 10 amp version and a 16 amp version. And the 10 amp version would supply maximum 2,400 watts, and the 16 amp version 3,840 watts. In a perfect world, when we would have 240 volts. But of course, we are not living in a perfect world, especially with power. So that's why we are always allowing 10% overhead. So instead of using 2,400 and 3,800, we would use a maximum load for these two products with 2,150 watts or 3,450. And then we can
Why we
power
need this overhead? That's my question.
on multiple reasons. So as I said, the LED wall, it could be that there is a very wide content on it, so it's going to consume 2000 watt, right?
Hmm.
And in addition to that, that leaves us also space to add equipment later on, when we're having some overhead, and it's also depending on the power quality. So just as an example, the 10 amp, the DSP 109, it in a perfect world with 240 volts, it's going to supply 2400 watts. But
Hmm.
when there are voltage fluctuations, when there's not enough juice in the line, and there are only 220 volts in the line, it's going to supply only 2,200 watts. So then we are falling below our maximum requirement, and then it could be that the LED wall is not starting, or that the network switch, for example, is getting clogged. So that's why we always need some overhead. Mostly, I'm explaining that with audio because everybody understands audio and how to spec or how to use a speaker. And mostly, all the big audio companies, they are suggesting you better use a very big speaker and turn it up only 20-30%. That's a better sound quality than using a very small speaker and turning up to 95 or 100%.
Okay,
And that's the
understood now.
same with power. So that's why we would use the 16 amp product, the DSP-169. And afterwards, we would just double check if there is some outlet restrictions because we're having solutions between 2 and 24 outlets. So we could also easily swap it if I would need more outlets. But after, yeah, our Defender Series Plus got 8 switchable outlets and one always on, and we're having just an installation with 7 devices that would work. So how would it look like in terms of wiring? We would put our Defender Series Plus in there, and then we would also split up the LED wall into 2 sections. So because LED walls, and that's the same with all big loads like uh, amplifiers, there as well, they're consuming a lot of power when they're getting started, and that's why we would split up the LED wall into 2 sections and connect it to 2 outlets of our Defender Series Plus, just to um, delay the start. So we can, and I'm going to show you that later, we can program sequences to start half of the LED wall now and in 2 seconds the other half of the LED wall, just to avoid that we are pulling a lot of power from the net and the circuit breakers are tripping or the voltage is going down, affecting all our other equipment. And the rest of the equipment, yeah, we would also connect to our Defender Series Plus to, first of all, remotely reboot it, but also more importantly to power to together the power consumption that we can also, in terms of green AV, that we can also cut down the power consumption. I'm going to show you that later on as well. I brought
I have
another,
a question for you.
yeah,
So I know we still need to connect Defender Series Plus, the device we've selected, to the power outlet. What's the amount of juice coming from the single power outlet from the wall?
from the wall. We're talking about the wall. So the wall is, again, in a perfect world, able to supply 3,800 watts.
Okay.
But mostly it's going to supply 3,600, depends on the voltage. That's, yeah, one outlet or one circuitry within the building, within the room.
One
Is
circuitry, not the outlet, right? We need to be sure of it.
It's, yeah, of course, it's a circuitry. It's the whole circuitry. So they are all backed up with circuit breakers, and it's the whole circuitry. So when you're having in a room 6 outlets on the wall, 6 wall sockets, then they are all together are going to supply 3,600,
Okay.
3,800 watts.
Okay. Thanks you. Thanks for the clarification.
No problem. I brought another example with me because then we are entering a bit higher power consumption.
Yeah.
LED walls are getting more and more popular these days, right? And we are not only having small in inverted commas, small LED boards with 120 inch, for example, but also big ones. So I brought an example of an 8 by 8 LED wall with me. That's, as you can see, almost 5 by 3 meters, mostly used in boardrooms, but also on airports for digital signage, for example. And there it's getting also a bit slightly more, I wouldn't say complicated, but we need to take into account a couple of other things. So the wiring diagram from this LED wall looks like this. So we're having 8 rows with 8 cabinets each. And we, first of all, again, we would, yeah, line out the
I
equipment.
assume you've tested several or at least few different LED wall configurators, right?
Yes.
Are they all nice like this one, showing the power consumption, amount of power lines?
Mostly, yeah. So mostly because the LED wall manufacturers, they know what one single cabinet is consuming in maximum and also on average. And mostly you get the maximum power consumption. If not, yeah, then sometimes we need to go back to the tech data sheet of
Hmm.
one cabinetry, and then we can calculate when the most cabinets they're consuming, depends a bit, but they're consuming about, yeah, 100 to 250 watts. And then we would of course need to calculate, okay, when I have an LED wall with 8 by 8, I would need to calculate then the single cabinet power consumption together, right?
I just want to tell that the viewers, if you have any, questions, or you are not sure about the outcome of this power LED wall configurator, you are not sure, or it's not showing the power consumption, and you need some help, we are here, and you will receive contact to me, to Martin after this webinar, so you can always ask question to us. We will help you to do it because Martin did it a lot of times, I believe.
I do, yeah.
Okay, so
That's
let's
why
go.
we're doing the webinar, right? To just demystify the power to, yeah, to make it
It's
simple to
not
understand.
complicated. Even I am capable of do it. But again, thanks to Martin, it's even easier.
Thank you. Yeah, so our LED wall, right? We would gather the power consumption, and in this case, yeah, the configurator shows the power consumption, so that's like 5,664 watts. And of course, we are also going to use the maximum consumption again, right? So not the
Hmm.
average one, because we need the maximum consumption for, yeah, for the worst case scenario with white content on it. So after having that, we would need to calculate the amount of SurgeX PDUs, because as we learned a second ago, we are supplying maximum in a perfect world 3,800 watts. So we won't cover the whole load with one PDU. So that's why we just, yeah, divide the complete load with our safe threshold overhead wattage, so the 3,450 watts, and that would mean I would need two SurgeX PDUs, and of course two separate circuitries with circuit breakers secured.
Hmm.
Then to make it easier, because we're having multiple outlets on the PDUs, to make it easier, we would calculate the single consumption per row of the LED wall, and that would be 708 watts. So that means we would connect, staying into this 3,450 watts, we would connect 4 rows of cabinetries to one SurgeX PDU. And then, yeah, we're already at the point where we can choose the right SurgeX SKU. Of course, the requirements is 16 amp product. So
Yeah.
mostly in LED world, we are not talking about the 10 amp product anymore because they are consuming so high loads. And we would need more than 4 outlets. So in this case, I've also chosen our Defender Series Plus, the DSP169. And as I said, we would connect 4 rows to each of them. So we would use the two of them and then, yeah, connect them uh, every single row to one single outlet. Because the advantage of that is we can then also program a sequence, and then we can start the rows one by one by one, just avoiding that the circuit breakers are tripping, that we're affecting other equipment like the network switch or
Hmm.
the signal distribution, so that the LED wall is being started smoothly and that it is running smoothly.
I hope you're going to show us how to do it.
Yes, I will do.
Fantastic.
And yeah, so the next how to I prepared for today is UPSs, because on UPSs there is also, yeah, a lot of vocabulary always mixed up, and that's why I just wanted to yeah, show you how we are calculating UPSs, that they are running also on a safe environment. Because mostly what we recognize is that the most UPSs, they are too small. So customers are coming back to us and asking when they're having like 2,000 watts of usage or of load. They are asking us for a 2 kVA unit, and that wouldn't work. And then they're just the batteries, they're running just on 2-3 minutes, and then it's going to switch off. So that's why I wanted to help you to understand where to or which UPS to choose and how to use the load with it. So we would again start with the power draw, right? I'm staying with my conference room, so we want to power the conference room. We know already that we're having 2,300 watts, and I want to power it for 30 minutes runtime. that should cover most of the issues within Europe. We're having, of course, in other countries much bigger problems with power, and but half an hour would be enough because mostly what we want to cover is that the service technician um, can get alerted via email
Mhm.
from our UPS, and then that they can react, right, and that they can shut down the equipment or start the diesel generator or whatever. So we just want to add another layer of security. And with the UPSs, we're also covering small power fluctuations. So sometimes it happens, and it happens everywhere. I'm using a lot of SurgeX units in my daily life, and I'm monitoring a lot of the power. I'm also using in my office, and I'm based in the Munich region in Germany. I'm also using them, and sometimes it happens that the voltage drops just for half a second to 180 volts, and then it's coming back up again. And mostly that's clocking equipment. That's clocking the Ethernet switch. That's affecting desktop computers. So that's what we want to avoid with the UPS in the back. So yeah, we're having 2300 watts, and then we would refer to our UPS range. So we can offer a lot of UPSs because we are our sister brand within our corporate. They are building UPSs between 200 VA up to 250 kVA. So we can also easily fill a room full of battery. But in at SurgeX, we are mostly um, focusing on the rack mountable UPSs because they cover the most of the needs of our partners. So that's our UPS range. So we're covering 1, 2, 3, and 6 kVA. And the 2 kVA, for example, supplies 1800 watts, the 3 kVA 2700, and the 6 kVA 5400. And that's also very important. What's always being mixed up is that the VA is the inlet power, but the watts is the outlet power. So mostly we're getting questions that somebody calculated 2000 watts as a usage or as a use case, and then they are asking for a 2000 VA UPS. But in fact, that's not enough because there's always an efficiency with the UPS, so it's not supplying 100% of the energy you're putting inside. It's not supplying 100% on the outlet. Ours are very good. They're having a power factor of zero point 0.9. So that means you're investing 1000 VA and you're getting 900 watts out of it. But that's quite important to lay out the UPS. And that's also what is being mixed up in the equation sometimes. And by the way, that's on every electrical product. That's the same thing. So you always need to invest slightly more energy into it to get a result out of it, right? And never mind if we're talking about an electrical motor, an UPS, or any other piece of equipment which works electrical. So that's why we are always also allowing 10% overhead to cover bad power conditions. So we would go with 1600 watts, 2450 and 4850 watts just to be safe. And again, that's the same conversation with as with the PDUs. You better use a slightly bigger device to power everything on a lower volume level than you are using a very small one running it on 100%. So then we would choose the right UPS, right? So we are again using our calculation with the 2300 watts, and we would choose the 3 kVA UPS as for now, because it's going to, in a safe
Mhm.
environment, it's going to supply 2450 watts. Um, and then we would need, of course, to cover the runtime. So we would need to double check, okay, so what's the runtime on 2300 watts? Or if we need to choose some additional battery cabinets. So we're also supplying battery cabinets with our UPSs where you can extend the runtime. It's not that we're changing the maximum power. That's not possible. I need to exchange the UPS. So when I'm having like a 2 kVA UPS and I want to supply 2500 watts, then I need to use a 3 kVA UPS. So I can't just add battery packs. It's it's a bit like with the car. So when you're on a car, when you're having a fuel tank, and by adding a battery cabinet, we would make the fuel tank bigger. So that means you can drive longer, but it's not going to drive quicker because we're not changing the engine.
Hmm.
So we're having a UPS runtime chart developed where you can see all our UPSs with runtimes, and that's a lot of numbers, and that's why I just wanted to guide you through how to read that properly and how to choose the right UPS and also choose the right amount of battery cabinet. So we have chosen the 3 kVA UPS, that's the 17302-60R, and as I said, we can see a lot of numbers and capacity and watts and minutes around. So that's why I wanted you just to guide you through. So again, our requirements, 2300 watts and 30 minutes runtime. Um, so how to find then the right UPS or the right battery cabinets? We would choose the next value to the load. So we would jump into the watts section and we would choose 2400 watts because yeah, it's slightly higher than the 2300 watts we would need, right? As a second step, we would have a look on the internal chart because the internal showcases what's the runtime on internal batteries. And as you can see, that's 3.6 minutes. Um, that's not enough, right? Because we would need half an hour. And that's why we would go or move on the same line because we're staying on the wattage. We're on the moving on the same line as long as we're having a value which is more than our 30 minutes. In this case, it's 31 minutes. So and then we jump back to the top of it, and where it says int plus text 2x, that means the 31 minutes is the runtime on internal batteries plus two external battery cabinets. So we would use the 3 kVA UPS plus two external battery cabinets.
And thanks to this set, to this bundle, we will get half an hour at least
Yeah,
power supply once the power is shut down.
correct.
Okay, that's cool.
Yeah. What I mentioned before already is, of course, we want to also monitor and reduce the power, right? So that nothing to do with the maximum power consumption, but in our daily life. And I've heard it from multiple countries in Europe now. The energy costs, they're getting higher and higher, right? So we want to help to cut down these costs. And
Yeah, actually, I have a question to our viewers about energy savings. So, just to get some feedback from you, uh, I asked the question about is this energy savings argument like a valuable for you, for your customers? Because sometimes yes, but we received a very responses for from different angles. Like, yeah, always our customers always asking about how they can save money, and energy is the point of discussion. But sometimes they're not. Okay, let's gather some more feedback and. Oh, we have a also question. So once we are gathering feedback about the questionnaire, but we have question, Martin, from Grzegorz. If we had load 2,400 watts, is better to use two times 1,200 watts UPS or a single one 2,400 watts? You can see it also if.
one second.
Okay.
Here we go.
Do you see it?
Yes, now. Um, It depends. It depends a bit on the case. So mostly I would suggest one UPS to cover all the load. Um, because it's in terms of when we're also, of course, looking onto the financial aspect, right? Then mostly it's cheaper to buy the bigger one than to buy two smaller ones. That's why I'm also always recommending, yeah, to use a bigger one. So we have it also, for example, some cases where a customer they wanted to cover like 800 watts for almost an hour, and they've chosen a 1 kVA UPS with, I think, six battery cabinets. And that's, first of all, it's a lot of equipment. So our UPSs, they're having 2U rack size. Except the 6 kVA, they're having 3U. So you need to have the space within the rack, right? That's one point. But a 1 kVA with six battery cabinets is much more expensive than a 3 kVA with one battery cabinet.
Is there any, situation, option, scenario when we should use this two times 1200 watts UPS instead of single one?
Yes, when you want to split up the circuitry, so when you want to put the 1200 watts onto two different circuitries, because could also be a scenario that you're having, yeah, one circuitry running the just the back end, just the signal monitoring, the Ethernet switch and the network, and on the other you're having just running the front end. So yeah, it could be also possible just to split them up into two circuitries, and then of course it's more useful to use two 1200 watt PSs.
Okay, okay, thanks. So the results of our questionnaire, yeah, they are more keen to, yes, there are the topic of energy savings is present, not all the time, but often or sometimes. And I'm quite sure uh, if we had had this conversation in the past, like 1 year ago, it will be in a different way. It will be very rarely. It's changing constantly,
Yeah.
right? Okay.
That's yeah, I mean that's because the energy pricings they're getting higher and higher, right? And then of course you need to, and that's I've had a conversation yesterday with a customer, and that's we found out that mostly the energy costs they are in the past they weren't taking into account because there is like a disconnection between I'm paying for the energy and I'm seeing the consumption. There's like a disconnect because most of us from private life, right, we're receiving once a year, we're receiving our consumption from the energy companies, and then we're paying for it because we used more or we're getting some money back. So that's not like in our daily cost included, right? And that's I think that's the disconnection where we are sometimes struggling to understand, or sometimes just I'm not getting very often asked for energy reducing or energy
Mhm.
savings.
Okay. Okay.
And that's why, we're doing also proper calculations, showcasing, okay, so that's the cost and that's how we can reduce it. And then a lot of our partners, they're really realizing that there is that you can save a lot of costs and at the end of the day, of course, also yeah um, act green and reduce our CO2 and everything. So I would use again our conference room scenario. And what we have done is we connected, of course, everything to the Finishes Plus, and we measured the power consumption. So that's the daily power consumption. So we're not talking about the maximum power consumption anymore. That's the really the daily power consumption. What we found out what the units they're using, right? And in a then we just made a calculation. We just said, okay, that's a 24/7 running installation, and we want to cut down the costs. And as you can see, the single conference room running 24/7 is using, yeah, almost 2,000 euros per year. That's now with 40 euro cents calculated, because it's a German scenario. And that's a lot of energy. And as we know, nobody's working in a conference room on the weekends and nobody's working there at night. What we have done is we defined a working day from 8 a.m. until 5 p.m. And then we installed one of our PDUs, and we scheduled the usage. So we just cut away the standby timing. So that means we program triggers that the installation is getting started 8 o'clock in the morning and that it's getting switched off 5 in the afternoon. And as you can see, we are almost saving 50% already, right? And when you are scaled that out to a conference center with 150 meeting rooms, that's a lot of money. Or we can also
Yes.
adopt it to other scenarios, like a big shopping mall after 10 p.m. when it is closed. We can switch off all the digital signage, the LCDs and also the LEDs within the mall, because there is no need to that they would run, right? The only or often what I hear back from system integrators is, yeah, they do let it run through the night because they don't trust that it's going to come up properly on the next morning. But that's also something we can fix with our sequences. We can also program how the equipment is getting started, making sure it's bulletproof, and you can easily switch it off in the evening, and in the morning the installation is going to start as expected.
Okay, but I see one issue with it. PCs like or room PCs or Microsoft Teams room solutions, they are often getting updates in the night.
That's
So,
correct.
switching them off completely for the night will cause issues because after some time they will be, outdated, the software on it, and it can create some problems. So can we do something about it?
Yeah, we could define like an update start so that it is going to back on and start it again. Or, of course, as you mentioned already, Microsoft Teams scenarios, we also know that we can't just, yeah, switch them off, that they need to run 24/7. So then we need to, of course, reduce our power savings. That's correct because we need it, right? We need it running.
Hmm.
But what we can fix, and what I've heard a lot in the last month and years, what we can fix is there is one. Sometimes there is a problem related with the update. So when the security update comes through, it's getting installed, and I've spoken to multiple system integrators, and they told me that it's likely to happen that the Microsoft Teams computer afterwards is getting clocked after they installed the update, and then somebody needs to restart it manually. And that's
Hmm.
what we can also fix. So we can make sure that it is running 24/7 and that it is receiving the security updates.
Okay, thanks.
You're welcome. Yeah, and so that's only the scheduling, but what we can also do is when we would combine our PDUs with a room booking system, for example, or a control system, then we could lower down the consumption on a daily basis. So not because actually we're running the equipment between 8 and 5, um, but when we would connect it to a room booking system, for example, and the equipment is just running when the room is booked. In this specific scenario, we found out that we can run it on 5 hours a day. So we are still scheduling it and switching it off. But in addition to that, we are also lowering down the daily consumption. So, and as you then can see, we're saving more than 70% of energy. And that's in terms of costs, right? That's a huge amount of money we can save. Um, and
Per
then
year.
that's per year, yeah. That's per year.
And
That's like 1,400 euros per year. And yeah, with this specific product, so the Defender Series Plus is 800 euros. end user price, so for the end user. So that would pay itself off after 8 to 9 months.
Okay, yeah. And just to addition to it, because our partners, they are often offering full solution for the room. So they will provide displays, they will provide video conferencing equipment, also maybe room booking system, control system, and signal distribution. So what we are trying to do, it's to add this power layer to this complex installation. It's often forgotten to add
Yeah,
it, and our partners, the reviewers, who can add it and offer it as a package, eco-friendly, lowering cost package. So SurgeX can be, not the must-have device, but really nice to have device to to save money in the long run.
yeah,
Yeah, there is this buzzword or buzz sentence, total cost of ownership. So just by adding one device, which will
yeah,
pay it off them itself after 8 to 10 months, you can get, lower the total cost of ownership for all the devices, during all the lifetime of the product.
yeah, that's true. As I said, it's going to pay for itself, the
Yeah.
SurgeX video. All right, so how to do that? That's what I wanted to show you in a live example. So,
But maybe just before we go to the to the web GUI of your device, I will launch yet another questionnaire. So, because the question is, we are talking about energy savings. For example, the case you presented, it's great to save the energy, but still, all the time, those devices, all of your devices, they are protecting from any power issues which may happen, right, in the
yeah,
power grid locally. So the question is, how often our partners, our viewers, experiencing any power-related issues during AV-IT installations, during their usage, is it common or not? Mm, In Poland, for example, I think the power is more or less stable, right? But this is not the case for all the countries we are working within as a Modulit. So let's ask this question and see what's
yeah.
the feedback.
See what's the feedback, and then let me explain what a power related issue is. Because
Yeah, yeah, of course.
that's mostly yeah what's getting we can't see the power, right? I mean, yeah,
Yes.
we with our PDUs we can see it, but we can't see the power. And in a lot of cases, there are issues in the installations, but they are related to power, but they are not in the head of the technicians. They are not yeah they don't think about the relation to power.
Yeah, so as you can see, it's like rather some or not really not at all. So it's not that common. Like there is a lot of this type of issues, but
Then maybe
the
you
the
need to
question
ask
is,
the second
what's the
question.
power issue, right?
Or you need yeah you need to ask another question. Yeah. So how often are you facing issues with the equipment? So
Yeah, yeah, and that's the next question we have for our viewers. So ghost errors, clocking issues, sudden restarts, without any pre-notifications. What's the ghost error? Please explain.
a ghost error is an error which you can't reproduce. It's like an Ethernet switch running for 3 weeks smoothly, everything good, and then it's getting clocked, and nobody knows why. And then it's running for 2 days, and it's getting clocked, and then it's running for 5 weeks again. So you can't, you won't find out the issue with it. Even
Mhm.
mostly, of course, the most technicians they are then starting to install firmware updates, and then it's running for a couple of days or weeks, and then it's again getting clocked.
Yeah.
That's a ghost error, so you can't reproduce the error. properly.
Yeah, exactly. And this ghost errors, clocking issues, this, sudden restarts, they are very often not, connected with the power issues. But
Yeah, so that's what we recognized within the last years. So then the equipment is getting blamed, and mostly it is not the equipment, it's the power supply. Because especially when you're having noise on the line, so when the installation is not properly done, or when there are big inductive loads within the circuitry, like air conditions, elevators, but also LED walls, amplifiers, they're affecting the power net, but we can't see it. We just, except we're monitoring it, but usually nobody is going to see it, and then the equipment is getting blamed for it. So why the KVM switcher is switching itself off after a while, and that's mostly these issues, they are power related and not because the software or the product is bad.
yeah. Okay. So we had these answers. So they are more or less very similar. So those ghost errors, clocking issues, they are not often connected with the power, but very often they
Fact,
are, like they are
in fact, they
related
are,
to the
yeah,
power quality.
that's true. And how we can see and monitor the power quality, that's what I wanted to show you. So this is, yeah, the Defender Series Plus product. It's
So
the one next to me.
what you did right now, you actually connected directly to the device inside your home office,
Yeah,
right? Through the network. So it's
yeah,
basically a web interface for the Defender Series Plus.
yeah. It's a web browser-based user interface where we can, yeah, remotely control everything. We can program it, but we can also monitor the power. So I would start with the power monitoring first. So we're having a live monitoring on the unit. So we are not just looking into the voltage, but also more importantly, the average power. There is no power because there's nothing connected to it. But we're also monitoring a lot other factors around the power to have, yeah, a proper fault finding tool. And on all the units, there is running, or there is a, there's a visualization running. So I can also, it's recording everything, and I can, yeah, just have a look. What's the historical power and where are the issues? I can look on everything we are monitoring, so not only the line voltage, but also the frequency and the average power consumption. And from that dashboard, I can export all the data into a spreadsheet. So I can visualize the power quality and also the power consumption. So that's why, yeah, we can collect
A
the data.
question, is this interface available for all your devices, or maybe this is just for the premium ones?
No, that's for all of them. So you're getting on all our devices, you're getting the network connected, of course, you're getting this user interface, and the functionality and the design is always the same.
So actually, our customers, can buy even the cheapest one and use it as a power monitoring tool for
Yes.
all the installations.
Correct.
Okay.
On all the SurgeX SKUs, it is running. The only thing what we are doing is, as I said, we're having solutions between 2 and 24 outlets. So the only thing which is varying is the number of outlets, right? After this is now my 8-way PDU, I got 8 plus one always on. So that's also monitored, but I can't switch it. And when something goes wrong, what I can do is, yeah, just hard reset. So switch off the power, I can hard reset the device, but I can also reboot it, for example. I can freely program the reboot time. So as you can see, the soundbar runs on 3 seconds, the MTR computer on 30 seconds. Why? Because there are devices like, yeah, NUCs, computers, um, but also there are Ethernet switches. They won't start again after 3 seconds rebooting. So that's why we would need a longer reboot time. So we can automatically, yeah, just reboot the soundbar and then it's going to come up after 3 seconds again. And that's in 90% of the cases, disconnecting the power to a faulty device will solve the issue. And in the rest of the 10% of the cases, mostly the equipment is broken. And then, of course, it's not behaving as it should be. And as I said before, we're monitoring it, but we're also working with the power. So we're having triggers. We can freely program the triggers. And first of all, after this is our background, we take care of the power. So when there is an overvoltage, for example, we're just switching off the installation to protect it. Asides our surge protection within the products, and all the products is our advanced surge protection included. But as a second layer of security, we're switching off, or we can switch off everything. I can also change thresholds, for example, to whatever 260, or it's a very sensitive installation, so I would go down to 250. And the energy saving bit, as I explained earlier, we can realize with schedules. So I got an energy saving trigger in here. This is weekly from Monday to Friday at 7 p.m. and I'm powering off all the outlets. I can freely define which kind of action I want to run. And in the morning, the start would be at 8 o'clock. And there I can also define a sequence. So it's not because we don't want to cause, of course, power issues when we're switching on everything at the same time. And that's why we can program sequences. So we can the power up, for example, in the morning.
I have a question.
Yeah.
How we can how we can avoid situation, maybe how we can solve the situation where, for example, there is a very urgent meeting in the night and we need to power up the equipment, but actually it's powered off. You know what I mean? Like
Yeah.
it will be some kind of out of schedule run the equipment need.
No problem at all. Then we can, through our cloud or through user accounts, we can just switch it on again.
Okay.
So there's the option to set up user accounts, for example, when the system integrator gets the is controlling the power, but they would need to as you said, switch
Can
on.
so maybe because it can be I can expect that this kind of situations can be very sudden, and the person who is doing that, they they will not have access to your account. But the question is, can we integrate, for example, Kramer control device like a touch panel where there will be button for turn all the equipment?
Yes, of course. So we can work with the grammar control system. We can work aside the control system. So we can, on the one hand, we can program the schedules and switching off all the equipment. But when there is an late management meeting, for example, our PDU would also react on the grammar control system. So when somebody turns on the room via the touch button, then of course it would come up again.
But we need to be sure that this Kramer control is outside this, the rule of switching off all the equipment. It should be running all the time, right? As an
Uh,
emergency.
Yeah, but the good thing is I can program the behavior of the trigger as I want to, right? So, for example, um, with the energy saving, it says power of all outlets now, but I could also just run a sequence, um, and I need to program now a sequence. So what I could do is program a sequence and taking into account that the touch panel and of course the control processor needs to run. So I can define, okay, I just want to switch on switch off, for example, just the LED panels, right?
Mhm. So actually, we can, for example, exclude single outlet from this running up devices sequence, right?
Yes. So
Okay,
I can
okay,
just
that's enough.
easily
Fair enough.
program a new, and for the energy saving, instead of switching off all the outlets, I would then just, power saving LED wall. So I would just switch off the LED wall and then the
Okay.
Ethernet switch, control system, or the Microsoft Teams computer would run 24/7. We can
Okay.
easily do that, yeah.
That's that's good.
And of
That's the
and of
answer I'm
course,
looking for.
of course, all our PDUs are also integrated with control room systems. So not only Kramer, but also all the other ones. So like Crestron or RTI or AMX.
Sure, sure.
What we also are making sure is that the installation is running 24/7. So that's why we can program. We have an auto ping function on board, so we can ping permanently an IP address. And when this IP address is not answering anymore, then we're having a ghost error on the equipment. So then we can just automatically reboot. In this case, now it would be the Ethernet switch that we would just. So we are already solving the issue in the background prior it comes up.
It's like auto healing.
It's auto healing the network, but we could also not only program the network in here because it's an IP address, so we don't care about the equipment which is
Any
behind it, right?
other network device can be.
Any other network device which gets an IP address, we can program it in there, and then when it's going down, like I mentioned earlier, the Microsoft Teams computer, when it's doing a software update and then it's getting clocked, our device would trigger that and would immediately hard reset it and get it up and running again. That the MTR is running 24/7.
Okay, that's cool. I like this feature.
Yeah, so that's what we can do from device side. So we can, and yeah, as we said,
I think the sequences are quite cool because you haven't mentioned, but actually I see potential here, for example, to set a lot of sequences for different scenarios, like for control rooms, where, for example, we need to set the network first because, for example, you have a AV over IP systems there, so we need to run the Ethernet PoE switch first, then wait like even 1 minute to start the network, start the PoE power supply, and then we can start other equipment, right? So we can do it like set delays after each step.
Yeah, so we are not saving, or we're not fixing only the electrical issues with the high loads, but yeah, as you said, also in functionality wise. So, and that's mostly the case, right? That the Ethernet switches, they're booting up slower than control processors, for example. And then there's always an issue because the clients within the networks they are missing for the control system, or as you said, the PoE is missing, so all the units they are not running. So what we can do is, just starting the Ethernet switch at the beginning, give it like 30 seconds or a minute to get the network up and running. And afterwards, then we're going to pull in all the different clients within the network. And that's not only we are using that, of course, on our scheduling. We can just make sure that the room in the morning is starting properly. But also more importantly, when there is no UPS in place, we can also program this sequence into the starting behavior of the PDU. So that means when there is a short power cut or a longer power cut, instead of everything starting at the same time, we run the sequence and we make sure that even if there is a bigger power issue, then we are still starting it with the sequence, making sure that the equipment is running smoothly after a power issue.
Cool.
Yeah, that's it around our user interface. As said, it's running on all the units. And what we have done, we also combined that into a cloud. And I just wanted to show you briefly the cloud. I know that we are running over with time a bit. So this is our SurgeX Connect cloud. And we developed like an estate management system. So this is my device list now. As you can see, uh,
So is it for free? It is, right?
yes, it is for free.
It's
And it's for
because it's
free.
beta, or it will be always for free?
No, no. We are going to remove the beta within the next couple of weeks, but it's always for free. So we're adding it to our products as a special feature. So we are hosting the servers, and what we want to do with the cloud is offer an estate management system. So as you can see, I got 3 units now up and running here, and these are all in my office, and they're connected. And what I've done is I defined different sites, so like the conference center and the control room, and also different locations. So I can define, okay, this is the Vertical Series Plus. It's running in conference center Warsaw, for example, and it's running in conference room number 3. And I can easily dial into it, or I'm going to use the Defender series that's running in conference room 121. Um, I can easily dial into it. I can see also the power monitoring, like on the
It's
user interface.
slightly different from the local interface, but it's just like a visual difference, or there is differences. There are more in-depth differences.
Mostly it's like 90% of the functionality from the user interface is here in the cloud. So as you can see, I can see the historical data. I can do power management. I can switch them on and off. Um, I can run the sequences, I can program triggers. So that's all the same functionality. The only functionality we are not allowing through cloud is making firmware updates. So for firmware
Okay.
updates, you need to be within the network, never mind if you're using a VPN tunnel or if you're on site and just, yeah, being directly connected to the unit. Why? Because that's a security reason. We're talking about infrastructure, we're talking about power, right? And sometimes it could be that there is an issue with the firmware update or that there's a power issue interrupting the firmware update. And then it could be that, yeah, that our PDU goes down, and then the software is not bricked, but is not reachable. And when you're then sitting on Bali, doing a firmware update in the middle of Krakow, for example, and it fails, then you are in big trouble, right? So
Yeah.
that's why we're not allowing to do security related stuff through the cloud.
So, from the other side, are there any functions we can do with the cloud, but we cannot locally?
Uh, yeah, we can line up all the devices. We can define the sites. Um,
Okay.
and yeah, the historical data visualization is a bit different. It's a bit easier to understand. So we're adding, as you can see, we're adding a lot of this information already in here. So
Hmm.
just makes it easier to understand because what we can do, what the system integrator can do, is also offering a bigger service to the end customer. So they can assign the SurgeX PDUs installed into their whole cloud dashboard. So combining several different customers, and then they can offer their customers their own cloud dashboard, and then they can see, of course, the end customer would see only the units they bought, right? Not from the other customers. And then they can, for example, jump in here doing monthly reports with yeah power consumption or if something went wrong.
Okay, cool.
Yeah, that's more or less about it, right? I mean, we are going to follow up with our product brochure. And finally, I just wanted to mention our latest product, the DisplayPack Plus. We are launching actually, and it's going to hit our warehouse in May. Um,
In
so
warehouse May, but I can say we already have some demo, some samples in
that's
Modulit Solutions. So contact your sales representative and we can arrange something for you because I think it's a very interesting device.
yeah. So the DisplayPack Plus is our smallest one. It's going to be available in 2 and 4 outlets, and mostly, I mean, you can use it in yeah applications where you need, of course, the full control. So this is running the same user interface, the same functionality, the same cloud connectivity like the bigger ones, right? So even if the form factor is small, the feature set is still maximum what you can get. And mostly, yeah, it's aiming into, of course, non-rack installations, um, where you have network installations or where you have also installations where there's a big distance between the equipment. Auditorium, for example, when you're having a projector on the ceiling and you're having some backwall speakers, and on the lecturer's desk you're having the signal management bit. The display plus can be we can then just add two or three
I see
into.
one more really nice scenario for this one. Like digital signage installations where you have like a screen and player, maybe some kind of a bit of network.
Yeah.
And actually, those small installations work as isolate islands. So I think it's recommended to add this kind of display pack solution to have to monitor the power of this small setup somewhere in the building, somewhere in the campus, somewhere in the mall center.
Yeah, it's not about only monitoring the power, right? So it's also making the installation bulletproof. So last week, for example, I spoke to a system integrator, and he's really looking forward to it because he's doing digital signage, and they're not allowed to use the network of the customer. So they are having, yeah, their own network, and they're using 5G routers to have the network. Then they're having an Ethernet switch, and they're using two displays to, yeah, display the advertisement, right? And they are going to spec it into their projects because they also really like the function that we can automatically reboot the network, because that's his biggest pain point. They are wasting a lot of service technicians costs, because the 5G router lost or loses the signal or goes down, and then they need to send somebody on site to, yeah, just manually restart it. And we can do that in the background. We make sure that it runs 24/7.
Totally. I like it.
Right.
And just to let you know, we have demo samples, and actually there will be some kind of nice. It's already here, like a starting promotion for this one. Buy more, get better price. More or less.
So,
More or less, yeah.
all right. Yeah. So that's it for today. We, wait, I just need to, here we go. Yeah. I hope now your understanding is a bit better with power and where we do fit into, yeah, the projects, and where we can also support you. So especially with our long run times. So just so that you know, on all the products is minimum 5 years warranty, and it's an advanced swap out warranty. So whenever something goes wrong in the field, just ring the sales managers from Modulit, and then we're going to exchange the product first. So we're not going to investigate 2 weeks and leaving you down. We want that your installation is running.
Actually, I'm not sure if this procedure is working because we never had any RMA about your products.
It's
So
true.
it's yet to be tested.
Yeah, but when there is an RMA, we're going to fix it quickly. But yeah, that's true. I've done the tech pre and after sales for a couple of years with the companies, with the SurgeX company, and RMAs were very seldom. So I mostly helped to spec in the product into the projects, and sometimes that's why, I mean, our RMA rate is so low. That's why we are also when something goes wrong, like, yeah, the cleaning person drops the water bucket and the UPS starts to burn through. Even then, we have had this scenario, and even then we're exchanging the product because we want to, yeah, we want to be a reliable partner, right? And we want to be a trustful partner.
That's correct. Okay, great. I see no questions from the audience, so we can slowly go to the end of our today's session. And because it's Friday, it will be a
Yeah,
good one.
that's a good idea.
Yeah. So thank you, Martin, for your time, for your expertise. And yeah, hopefully we see each other in coming weeks during the events.
Yes, we'll do.
And for the rest of you, please remember that, this power-related issues, it's not like a very popular thing here on our markets. That's why we are offering not only just part numbers for you can buy, but also the all the support around it in no in on every stage of the project. So if it's not clear for you which device you need to select or how to handle specific power issue, then don't hesitate. Reach me, reach Martin, reach our sales managers, and
Yeah,
together we will help you. Because I genuinely think that adding a SurgeX device, not as a must-have device for all the installation, but like a very nice to have energy savings, power protection device, it will save a lot of money for the customer and for
a lot of
you.
stress and service burden,
Yeah,
yeah.
yeah,
And we can also help with application diagrams, with use case scenarios, just to get your customers the right understanding why they should invest.
yeah.
I would say it's mandatory because it's power. We're doing power, so we can power up every
Okay,
installation.
let's call it mandatory.
All right. So, yeah. Thanks a lot also from my side for attending today's webinar. I really enjoyed it and see you
Thank you.
soon.
Thank you all. Thank you, Martin. And I wish you all great weekend.
Have a great weekend. Bye bye.
Bye.